What up, what up? I'm the math teacher Goat, and this full lesson in AP Precalculus is about the sine and cosine function graphs. Yes, we're finally going to graph these guys. Make sure you go to the description, download the notes, follow along. Make sure you also like and subscribe. Leave a comment, please. Goes a long way for me. Let's review by redoing the unit circle. Okay, so that's the first thing that we're going to do. Our review for the day, or our warm-up for the day, is redoing this unit circle the way I showed you in the previous lesson. Now, I'm not going to go as slowly as I did before. I'm not going to, take my time reminding you what the degrees and what the radians are. Hopefully, as you've studied this and looked at this, you feel a little bit more comfortable. But let's just take a look at the degrees versions of this first, all right? You start out at 0 degrees all the way on the right or the positive x-axis. You'll end up with 360 degrees. You are 30, you are 45, you are 60. First right angle is a 90. Then you have 30 more than that, which is 120. 45 more than 90, which is 135. And then 60 more than 90, which is 150. On the other side, you're at 180. And then you're at 30 more than that, so 21 with a 0 on it, 45 more than that, 225, 60 more than 180 is 240. Over here you're at 720, then 300, which is 30 more than that, 45 more than that is 315, and 60 more than that is 330. Now, we don't really care about the degrees as much. We care about the radians, so that's a little bit more tricky to memorize. You start at 0, you end at 2 pi. This is pi over 6 because it's the same as 30 over 180, and then you just attach a pi to it. This is pi over 4 for the same reasons. This is pi over 3 for the same reasons. This is pi over 2 because it's half on its way to 180, so pi over 2. This is going to be 2 pi over 3 because it's 2/3 of the way to pi. This is going to be 3 pi over 4 because it's 3/4 on the way to pi, and then 5 pi over 6 for those same reasons. Here's my pi, and these guys are just adding 1 to all of these. So you have 7 pi over 6, 5 pi over 4, 4 pi over 3. This is 1.5 pi, so 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. All right, now the way that you build the numerical values, let me blow up a little bit and scooch in a little bit. I think that's okay. The way you build the point values is you take a look at what these points are exactly on the axes. So this right here is the point 1, 0. This right here is 0, 1. Okay, this is quadrant 1. Your quadrant 1 values are positive positives. Always start out and you're building up and you're thinking square root of 3, square root of 2, square root of 1, all over 2. So what I do is I take my x value closest to the axis, x-axis, I write out root 3 over 2, root 2 over 2, root 1 over 2, which is just 1 over 2, then work my way back using the same exact numbers, root 3 over 2, root 2 over 2, and root 1 over 2, which is just 1 over 2. Since this is quadrant 1, I don't need to worry about making negatives because they're both positives. Now moving on to quadrant 2, right? We are doing the same exact thing, but we're reminding ourselves that quadrant 2, the x values are negative and the y values are positive. So you start with your point, your x value closest to the x-axis, and you do the same thing here. Root 3 over 2, root 2 over 2, root 1 over 2, root 3 over 2, root 2 over 2, root 1 over 2. The x values are negative, so put negatives in front of the x values. Those are your guys. That's -1, 0. Easy peasy. Quadrants 3 and 4. So let's quick label the easy one here. 0, -1. This is quadrant 3. All values are negative. So let's start with the x value closest to the x-axis and do that again. Root 3 over 2, root 2 over 2, root 1 over 2. Work your way back. Root 3 over 2, root 2 over 2, root 1 over 2. negative, 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 negative. Last but not least, quadrant 4. Positive x's, negative y's. Start with your x value closest to the x-axis. Root 3 over 2, root 2 over 2, root 1 over 2, root 3 over 2, root 2 over 2, root 1 over 2. Positive x's, negative y's, so throw negatives in front of the y values. And that, all of my darling friends, is the unit circle once again. So we're going to be using these values kind of to build sine and cosine graphs, see what they look like. But again, it's very important that we feel good about the unit circle. You're going to have to memorize it. You're going to have to use it all the time. Yes, a problem that I created. I always love these. The euthanasia coaster is the name given to the hypothetical steel roller coaster designed with the sole purpose of killing its passengers. Sketch a graph showing the height with respect to time, starting the moment the rider hits the bottom of the initial hill. Okay? So, a fake problem with a fake roller coaster. Okay? We go up, we go down. This is where our graph begins. So we'll say that we're just a little bit above the ground. My height is going to go up and then down, and then up a little bit less, and then down to the bottom, and then up a little bit less, and then down to the bottom. So up and then down, and then up a little bit less and down, and then up a little bit less and then down, and you get the idea. We get this wavy looking thing that is graphed because the height just lessens every single time. Now the bottom is supposed to be the same exact number, so ignore the fact that my picture isn't perfect. They rarely are. But what we have here is as the height fluctuates, we get this wavy looking picture. Why did I give you that when we're about to do this? Well, you'll see in a minute. So let's take a look at what happens to these graphs as we graph them, okay? I'm going to now use that waviness to show you what the sine graph looks like. In order to create the sine graph, we have to understand that sine is the y value. Okay, so essentially what I'm going to do is as I spin this dot around, as my angle changes, what is the height compared to the x-axis? Okay, so in other words, as I'm right here starting out at 0 degrees radians, what's my height? Well, it's at 0. As I spin it around, my height is increasing, 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 and then it's going to peak out right at here at pi over 2. What is my height now? Well, if the radius is 1, my height is going to be y equals 1. Then this dot is going to come back down at pi. We have a height of y equals 0 again. So here we are at y equals 0. And then I'm going to keep spinning around to 3 pi over 2, where my height is now going to be 1 unit below the x-axis. So y equals negative 1. And then we keep spinning around, and at 2 pi we repeat. So if I were to draw a really rough sketch of this, this is what I know so far, okay? It peaks out at 1, it bottoms out at negative 1. At 0, we were at 0. Then all of a sudden we move up here to pi over 2. And at pi over 2, we were at 1 unit above the x-axis. Then we come back down to pi, and at pi, we're at 0 again. Then we move along to 3 pi over 2, and at 3 pi over 2, we're 1 unit below the x-axis. Then we come back to 2 pi, and at 2 pi, we're 0 again. And then this process would keep repeating because it'd go up to 1, 0, negative 1, 0, 1, 0. So this would just keep repeating, dots up, down, middle, up. You get the idea. Now, we saw from the euthanasia coaster and all the other, Ferris wheel problems that we've done that this isn't some jagged, zigzaggy looking thing. This is going to be a nice, curvy looking wave like that. And it'll repeat, repeat, repeat. So let's turn that guy into the actual graph down here. We're at 0. This is 2, so let's mark off 1. Right there. Let's mark off negative 1. At 0, we're at 0. At pi over 2, we hit 1. At pi, we're at 0 again. At 3 pi over 2, we hit -1. At 2 pi, 0 again. Repeating the process has me going up to 1, down to 0, down to -1, and 4 pi again. This is a nice, wavy looking curve. So we're going to go up, we're going to peak out, we're going to cross through, become concave up, bottom out, still concave up, cross through, now we're concave down. Okay, now we're decreasing, concave down, hit an inflection point to become concave up, decreasing, but now we're concave up, increasing. Look at all those words that I've been using, and look at that picture. Not bad. What's the amplitude? Well, the amplitude is half of the total height. So from 1 to -1, we have 1 minus -1. Half of that is going to be half of 2, so the amplitude is 1. No big surprise there. The period is how often it takes for it to repeat. So if we're here at the tippy top at 1 at pi over 2, and then it repeats at 5 pi over 2, 5 pi over 2 minus pi over 2 is a period of 2 pi. So what we know is the graph of y equals sine x starts on the origin. It goes up to 1 at pi over 2, crosses back to an inflection point at pi, down to -1 at 3 pi over 2, and repeats every 2 pi because the period is 2 pi. Now this keeps going to the right, and it would keep going far to the left. This is an infinite graph left to right that has a range of -1 to 1 and a domain of everything. And it just waves and is periodic. That is the sine graph. The cosine graph is going to follow the same exact steps, but I made a little typo here, so I did make a little typo here. So let's fix that. My typo is I meant to say what happens to the x value as it spins counterclockwise. Cosine is the x value. So right here at the angle 0, I have an x value of 1. As we hit the angle pi over 2, my x value is now at 0. As we go over to pi, my x value is now at -1. And as we come back down here to 3 pi over 2, my x value is 0 again. And then repeat. So x is 1, 0, -1, 0. 1, 0, -1, 0. So drawing a very rough sketch of this, right? I peak out at 1. I bottom out at -1. Right away, we're already at 1. Then at pi over 2, I cross the x-axis because I'm at 0. At pi, I'm down to -1. Right there. At 3 pi over 2, I'm back at 0 again. And at 2 pi, to reset, I'm at 1 again. My phone agrees with me. Now, knowing very well from what we saw up there, I'm not just going to go zigzag and draw some type of V-looking thing. I'm going to know that as height changes, it does so in a nice, smooth fashion. So we're going to have this concavity-looking, concave up, concave down-looking thing. But what I have is this is cosine now. And cosine didn't start at the origin. Cosine started at 1, bottoms out at -1, and then peaks out at 1 and then repeats the process. So let's go down to our graph here and let's label some things. So you're 1, you're -1. And according to our graph, we start out at 0, 1. We hit an inflection point at pi over 2. We bottom out at pi. We hit 0 again at 3 pi over 2. We peak out at 1 and repeat the process at 2 pi. So another half pi after that is going to be at 0 again. A full pi after we repeat is going to be at -1. 1.5 pi after that is going to be 0 again. And then repeat every 2 pi. So we draw ourselves a nice curve to the best we can, concave down. We hit an inflection point, concave up increasing, increasing, concave down, decreasing, inflection point, concave up decreasing, minimum, concave up, inflection point, maximum value, done. What is the amplitude? 1 again, because it's half of the total height, so I won't do the math. What is the period? Look, you start at 0 at the very tippy top, and then at 2 pi or at the very tippy top again. The period is also 2 pi. So sine and cosine behave the same way. They look almost exactly the same. It's just a slight difference between the two is sine starts at the origin here, and cosine starts at 1. So these guys are the same exact things, just shifted over half a pi. I mean, if I were to move sine over to the left starting here at half a pi, you'd have literally the same exact graph. So these guys are exactly the same graph, just with a horizontal shift of pi over 2. Now, we need to memorize what sine and cosine looks like. Okay, so hopefully you got the idea. We don't need to completely break down what it looks like again. I just want to draw sine x 3 times on pi over 2. So again, sine starts at the origin, at half a pi, peaks out at 1, bottoms out at pi, goes to -1, and then 2 pi. Draw yourself a nice little wavy looking thing. Looks like that. Do it again. Started at 0, 0, peaks out at 1, halfway through at pi, bottoms out at 3 pi over 2, repeats at 2 pi, wavy, concave down, inflection point, concave up, period is 2 pi. Then you do it again. Start at 0, 0, at 1, or I'm sorry, at pi over 2, you're at 1, at pi, you're at 0, at 3 pi over 2, you're at -1, 2 pi, inflection point, concave down, still concave down, decreasing, inflection point, decreasing, concave up, minimum, concave down, increasing. Okay? Where is y equals sine x, these graphs right here, increasing and decreasing? Well, according to our pictures, and we're only answering these on pi, or from 0 to 2 pi. So we're just answering these from 0 to 2 pi, no more than that. Where is y equals sine x increasing? Well, it looks like it's increasing, so we'll put increasing. It looks like it's increasing from 0 to 2 pi. I'm going to include 0. And did I say 2 pi? Pi over 2. It's going to stop increasing at pi over 2, but we're not going to include pi over 2 because at the very tippy top, it's neither increasing nor decreasing. Are we done? Nope, because now it's decreasing, and then it hits increasing again from 3 pi over 2 to 2 pi. So union, not include 3 pi over 2, but do include 2 pi because it's still going to be increasing at 2 pi. Where was it decreasing? Well, it was decreasing from the maximum here to the minimum there. So from pi over 2, not including pi over 2 because at the very top it's neither increasing nor decreasing, to 3 pi over 2, and we're not going to include 3 pi over 2 literally for the same exact reasons. On this interval, what are the inflection points? Well, the inflection points are where they change concavity, and that happens at 0, pi, and 2 pi. Where is y equals sine x concave up and concave down? Well, given the interval 0 to 2 pi, it's going to be concave. We'll go concave up first because that's the order that they want it in. And by they, I mean me. I made this problem. Concave up is going to be from pi to 2 pi. You're not going to include pi, and you're not going to include 2 pi because those are inflection points. Don't include either of those. It's going to be concave down from 0 to pi. Don't include either. What quadrants is sine x positive and negative? All right, well, we have quadrant 1, we have quadrant 2, quadrant 3, and quadrant 4. Sine is above the x-axis, which means it's positive from 0 to pi, not including. So from 0 to pi, sine is positive. So 0 to pi is going to be 0 to pi, which means it's positive in quadrant 1 and positive in quadrant 2. It's going to be below the x-axis from pi to 2 pi. So from pi to 2 pi, it's below the x-axis, which means it's negative in quadrants 3 and negative in quadrants 4. All right? So fun information about sine. There you have it. Let's take a look at cosine. Draw cosine x 3 times on the interval 0 to 2 pi. Cosine started out at 1, and then at pi over 2 hit 0. At pi hit negative 1. At 3 pi over 2 hit 0, and repeated at 2 pi. Concave down, inflection point, concave up decreasing, minimum, concave down increasing, up increasing, concave down increasing. Do it again. Start at 1, pi over 2, pi, 3 pi over 2, 2 pi, 1, 0, negative 1, 0, 1. Wavy, 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 concave down, that looks bad, concave up, minimum, inflection point, concave down to a maximum. One more time. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. Decreasing, decreasing, minimum, increasing, increasing, maximum. So looking at these pictures and answering only for that interval, where is y equals cos x increasing and where is it decreasing? Well, it starts its increase at pi and stops increasing at 2 pi. So we're not going to include pi because at the very bottom it's doing neither. And we're not going to include 2 pi because at the very tippy top it's not doing either. That's the increasing. It's going down and to the right, decreasing from 0 to pi. Don't include 0, don't include pi. On this interval, what are the inflection points at pi over 2 and 3 pi over 2? We had 3 in the last one, 2 on this one. Okay? Where is cosine x concave up and where is it concave down? Well, it starts concave down, but then begins concave up at pi over 2, but not including pi over 2, and then stays concave up until 3 pi over 2, where it hits an inflection point again. Where is it concave down? It starts out concave down at 0, hits an inflection point at pi over 2. Don't include either of those. Actually, we can include 0. We can include 0, so we will. It goes concave up for a little bit, and then begins being concave down again at 3 pi over 2, all the way to 2 pi, and we can include 2 pi. Now, cosine are the x values. Where are the x values positive on a coordinate plane? Well, here and here. It's negative here and here. So how's that going to apply to here? How's that going to be the same thing here? Well, cosine is above the x-axis from 0 to pi over 2, which means in quadrant 1, it's positive. Cosine is positive, again, which makes sense because the x value is positive. In quadrant 2, we're negative. In quadrant 3, from pi to 3 pi over 2, we're negative again, Makes sense. On the left side of the x-axis, the y-axis, I mean, on the left side of the y-axis, you have negative x values. And then once we come back over here to quadrant 4, we're going to have positive x values again, which makes sense because the graph up here is above the x-axis. So we're putting stuff together. Let's answer a few questions and be done with it. All right, let's answer a few problems. These guys are awful. These guys are just gross, but you'll see them. You'll see them. We are given an angle theta. There you are. It looks to be somewhere in quadrant 2. I don't know. It's in standard position shown in the figure. The function g is given to us by g of alpha equals cosine alpha. For any angle alpha not shown between theta and 3 pi over 2. So before I go any further, I have an alpha angle that lives between theta, so it could start here and end somewhere at 3 pi over 2. So my alpha angle, okay, could end on this dot here. It could be here, 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 it could be here. Any of those possibilities, okay? Which of the following is true? So I need to compare g of alpha and g of theta. Well, the g function is a cosine function, which means the x value. So, at this very moment, g of alpha and g of theta are the same. Okay? When I move this to the left counterclockwise just a little bit, the x value on the red dot is smaller than the x value on the black dot. So if the x value on the red dot is to the left of the x value of the black dot, we at this moment can say g of alpha is less than g of theta because the x value is smaller than the x value here because the x value on alpha is smaller than the x value of theta. Is that always going to be the case? Right now it's not, right now it's not, right now right now it is, it still is, it still is, it still is, it still is because it's to the left of it, it still is, it's to the left of it, but wait a minute. Around here, the red dot is an x value. The black dot is an x value. They are exactly the same. At this moment, the x value of alpha is the same as the x value of theta. So that is true. By the way, can I keep moving the red dot? Yup. If I move it a little bit further, I could stop it here. So right now at this moment, the x value of my red dot is 0. And this has a negative x value. So at this moment right here, my red dot has a higher x value than my black dot. In other words, my alpha value is larger than my theta value. So, which of the following is true? Alpha is smaller than theta, sometimes. Alpha is greater than theta, sometimes. Alpha is equal to theta, sometimes. Depending on the value of alpha, sometimes it's less than, sometimes it's greater than. And you know what? Sometimes it's equal to. Well, not sometimes, but one time. Very, 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 very strange problem. Let's do another one. It's going to be similar. See what we come up with there. We are given angle theta again. The function g is given to us by cosine again. Okay, so again, we're looking at the x value. X value only. Angle alpha is not shown, but alpha is going to be in between theta and 2 pi. Theta and 2 pi. So 2 pi is all the way at the very end here. Okay, so we have an alpha there. And we are going to be asked for the x value and where they are, I think we're going to get the same exact answer. So basically, at this moment right here, the x value, oh, I meant to do this, the x value for alpha, ignore that squiggly, the x value for alpha is smaller than the x value for theta. So we could say that g of alpha is less than g of theta. That's still the case, 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 that's still the case. Here, g of alpha is equal to g of theta because the x value for alpha is the same as the x value for theta. And then if I keep going to 2 pi, now it's to the right of it. So the x value is to the right for alpha than it is for theta. So g of alpha is greater than g of theta. So which of the following is true? The same exact thing. Depending on the value of alpha, sometimes it's bigger, sometimes it's smaller. Yeah, I didn't pick really good examples for that one. You just got the same exact thing twice. Not a fan, but that is what you get. All right, let's wrap this guy up. For the function g of theta equals sine theta, what are all the values of the domain? And the domain, by the way, is the interval 0 to 2 pi, where g of theta equals 0. All right, so this is sine. I'm going to draw a rough sketch of sine. Okay, sine starts at 0, 0, peaks out at 1 at pi over 2, hits 0 again at pi, at 3 pi over 2, hits negative 1, and then repeats the process at 2 pi. So up here, 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 here. So we care about when it's 0. All right, well, this hits 0 in 3 different spots on 0 and 2 pi. It hits it at theta equals 0, it hits it at pi, and it hits it at 2 pi. Basically, when it's 0, it's the inflection point. So we kind of answered this problem earlier today. It's a different version, a different look. Now we have cosine. I'm going to draw a picture of cosine, sketch it. Starts out at 1, bottoms out at negative 1. So starts out at 1, at pi over 2, it hits 0. At pi, it bottoms out at negative 1. At 3 pi over 2, it hits 0. And at 2 pi, it hits 1. Curvy, curvy, curve. Curvy's dreamland. It's a game. Look it up. We care about when it hits 1. Well, it hits 1 at 2 spots, here and there. So on the interval, it hits 1 at theta equals 0 and theta equals 2 pi. Now, one of the things that we look at that I didn't really touch on at all today, okay, is if I go back to some of these previous pictures, sine and cosine go on forever left and right. Sine and cosine go on forever left and right. So you will see problems, and for this, I just kind of stuck to positive x-axes and stuff like that. But we could draw these out and really expand these. Like wow, that's awful. Like if I wanted to draw sine, I know sine looks like this, repeats at 2 pi, goes and does that again, repeats at 4 pi, which also means it goes like that, and at negative 2 pi, it repeats and then does that at negative 4 pi. Okay, I know it does that. That's sine. Similarly with cosine, okay, similarly with cosine, I could draw a very similar picture. Let me try to do a little bit better job with this. There we are. It starts up here at 1 and then repeats at 2 pi. Repeats at 2 pi, so here we are at 4 pi, which means going to the left, it goes down and then back up at negative 2 pi, goes down and then comes back up and repeats at negative 4 pi. So let's not forget those rules, okay, just for future problems, But that, ladies and gentlemen, does take care of section 3.4. So as usual, I'm going to recommend that you go to my YouTube channel and search up AP Precalculus 3.4 and see some of the questions that show up in my random AP Precalc example things. Just to further your knowledge, it'll do you some good. Also, if you're watching these on the courses, the playlists will just kind of fall into place. But like, subscribe, watch my videos, comment, stuff like that. Let me know if I make mistakes. It happens a lot. But also tell me how much you love me. Have a good day. Thanks for watching. Bye.